Hello learners, on behalf of Indira Gandhi National Open University, we welcome you to this video lecture session. Today's topic is probability theory. This is the 16th module for the course Quality Engineering and Management. I am Professor Subhashish Maji from School of Engineering and Technology of Indira Gandhi National Open University. So today's topic is probability theory. After listening to this video lecture, you will be able to understand the probability theory, you will be able to know the probability distribution, you will be able to explain the normal distribution, exponential distribution and variable distribution, and you will also be able to solve the numerical related to probability theory. A probability is a numerical statement about the likelihood that an event will occur. The likelihood of a dice showing 4 in a single throw is 1 in 6. The occurrence of head or tail while tossing a coin is 50%. In tossing a coin, the occurrence of head excludes the occurrence of tail. These events are not influenced by external causes and have equal chances of coming. Such events are called mutually exclusive. The events are called collectively exhaustive if they include all possible outcomes. Since obtaining a head and tail represents every possible outcome, they are collectively known as exhaustive. Consider the event of drawing the number 7 and drawing a heart from a pack of 52 cards. Neither of these are mutually exclusive events because a card with heart and number 7 can be picked up. Also, they are not collectively exhaustive because there are other cards in the pack besides 7s and hearts. There may be clubs, there may be diamond, there may be spade, and apart from 7 we can have 1, 2, 3, 4, 5, 6, 8, 9, 10 also. Let us talk about the probability theory. If A events are favorable to an event E and total number of events that can occur is B, then probability P of the happening of an event is defined as the probability P is equal to number of favorable cases divided by total number of exhaustive cases. So P is equal to A by B. Also, the probability of failure Q or event A not happening is given by Q equal to number of unfavorable cases divided by total number of exhaustive cases. So if A is favorable out of total chances of B, so unfavorable cases will be B minus A and total number of exhaustive cases are B. So Q is equal to B minus A by B, that is equal to 1 minus A by B. But A by B you have already calculated as P. So Q is equal to 1 minus P. Thus P plus Q is equal to 1. So probability P is greater than or equal to 0 and less than or equal to 1. And Q is also greater than or equal to 0 and less than or equal to 1. From the above, the two basic statements about the mathematics of probability can be stated as: number 1, the sum of the simple probabilities of all possibilities outcomes of an activity must equal to 1. Number 2, the probability P of any event is greater than or equal to 0 and less than or equal to 0. These statements are illustrated with the events of rolling a dice. It has 6 possible outcomes. If you throw a dice, the outcome will be either 1 or 2 or 3 or 4 or 5 or 6, because the dice is having 6 faces and onto the faces the numbers are printed. Either 1, 2, 3, 4, 5 or 6. So if you throw a dice and you will see any of these numbers on the top. The possibility of occurrence of number 1 in a throw is obviously 1 by 6. Similarly, the probability of occurrence of number 2 is 1 by 6. Since all the outcomes are mutually exclusive, they have the same probability, that is 1 by 6. The sum total of all these probabilities is 1 by 6 plus 1 by 6 plus 1 by 6 6 times. So that comes out to be 1. Hence, statement 1 is true. Also, the individual probabilities are less than 1. Thus, statement 2 is also true. Additive law of probability. The probability of occurrence of any A exclusive events E1, E2 or En is equal to the sum of the probabilities of the occurrence of separate events. So, P within bracket E1 plus E2 plus till En is equal to PE1 plus PE2 plus PEN. Consider the event of drawing a spade or drawing a club out of a pack of cards. These are mutually exclusive since drawing a spade does not involve drawing a club. Thus, P spade is equal to 13 by 52 because the number of cards for spade is 13 and the total number of cards is 52. So, probability of drawing a spade is equal to 13 by 52. At the same time, the probability of drawing a club cards is 13 by 52. Hence, P, that is probability of drawing a spade plus club, is equal to probability of drawing a spade plus probability of drawing a club cards. That comes out to be 13 by 52 plus 13 by 52, that is equal to 26 by 52 is equal to 1 by 2 or 50%. If two events are not mutually exclusive, then the probability of both events occurring together must be subtracted from the sum of the probabilities of individual events. So, the probability of E1 or E2 is equal to probability of E1 plus probability of E2 minus probability of E1 and E2. Consider the event of drawing a 4 or a diamond out of the pack of cards. These events are not mutually exclusive as there is a card with the number 4 and having a diamond. Thus, probability of drawing a 4 is equal to 4 by 52 and probability of drawing a diamond cards is 13 by 52 and probability of 4 and diamond is equal to 1 by 52 because there are 4 cards whose numbers are 4 and there are 13 cards for diamond and there is only one card which is 4 and diamond. Hence, P4 and diamond, that is probability of drawing a 4 and diamond, is equal to probability of drawing a 4 plus probability of drawing a diamond cards minus probability of drawing 4 and diamond. So, this will be equal to 4 by 52 plus 13 by 52 minus 1 by 52, that comes out to be 4 by 13. Multiplicative law of probability. When the occurrence of one event affects the probability of occurrence of some other event, the events are said to be statistically dependent. The probability of the simultaneous happening of two events, E1 and E2, is equal to the product of probability of E1 and conditional probability of E2, given that E1 has already occurred. So, probability of E1, E2 is equal to probability of E1 multiplied by the probability of E2 by E1, or probability of E1, E2 is equal to probability of E2 multiplied by probability of E1 by E2. In order to illustrate this concept, consider the following problem. Assume a bag contains 10 balls of the following descriptions. 5 are grey and lettered M. 1 is grey and lettered K. 2 are black and lettered M, and 2 are black and lettered K. If a ball randomly drawn from the bag is black, find out the probability that the ball is lettered K. The probability of choosing a grey ball lettered M is PGM is equal to 5 by 10, that is equal to 0.5, because there are 5 grey balls lettered M and total number of balls are 10. Similarly, the probability of choosing a grey ball lettered K is PGK is equal to 1 by 10, that is 0.1. The probability of choosing a black ball lettered M is PBM is equal to 2 by 10, that is equal to 0.2. The probability of choosing a black ball lettered K is PBK is equal to 2 by 10 is equal to 0.2. The probability of choosing a grey balls, that is PG, is equal to PGM plus PGK is equal to 0.5 plus 0.1 equal to 0.6. The probability of choosing a black balls, that is PB, is equal to probability of BM plus probability of BK, that is equal to 0.2 plus 0.2 is equal to 0.4. The probability of choosing a black lettered K is probability of K, that is equal to PGK plus PBK is equal to 0.1 plus 0.2 is equal to 0.3. Now the joint probability of a ball being lettered K and black. So here you see we are interested to calculate probability of BK is equal to probability of B multiplied by probability of K by B. So here probability of K by B, from that expressions we can get probability of BK divided by probability of B, that is equal to 0.2 divided by 0.4 is equal to 0.5. The term P K by B gives the probabilities of choosing a ball lettered K given that it is black. That is, the term P, that is the probability of B oblique K, gives the probabilities of choosing a black ball B given that it is letter K. So probability of B oblique K is equal to probability of BK divided by probability of K, that is equal to 0.2 by 0.3, that comes out to be 0.66. Now multiplicative law of probability. Events are said to be statistically independent if occurrence of one event does not affect the probability of occurrence of some other event, the joint probabilities of the two events E1 and E2 occurring together is simply the product of the occurrence of each event independently. That is, probability of E1 E2 is equal to probability of E2 multiplied by the probability of E1. For example, the probability of tossing a 6 on the first roll of a die and 5 on the second roll is probability of tossing a 6 multiplied by probability of tossing a 6 is equal to 1 by 6 multiplied by 1 by 6 is equal to 1 by 36. Now let us talk about the probability distribution. If an experiment is performed on variable x and it takes value a, then the probability of this event is denoted by probability of p within bracket x is equal to a. Such a variable is termed random. Suppose the event is x is less than a, the corresponding probability is denoted by p within bracket x less than or equal to a. For the event capital X greater than a, the probability is p within bracket x greater than a. These two events are mutually exclusive because if the event x is greater than a occurs, the other cannot. Hence, p within bracket capital X less than or equal to a plus p within bracket capital X greater than a is equal to 1. Now let us discuss about the probability distribution. The random variable x is said to be discrete if it can take at most the countable number of values denoted by xi, where I is equal to 1, 2, 3 till capital N. Here n is a number which can tend to infinity. Let x1, x2 be the values for which capital X has a positive probability, that is p1, p2, then the probability function of x can be defined for each x as fx is equal to pj, where x is equal to xj and j equal to 1, 2, 3 up to n, or 0 otherwise. If the probability function is known, then for any unique number, the probability can be determined, that is called the probability function of the random variable x for any a and b, where b is greater than a. The probability that capital X is greater than a but less than or equal to b is probability of x greater than a less than or equal to b is equal to probability of x less than equal to b minus probability of x less than a is equal to fb minus fa, where probability of x less than or equal to x depends on the choice of x. It is a function of x which is called the distribution functions of x and is denoted by fx. The measures associated with the probability distributions are expected value and variance. The expected value is the weighted average of the values of the random variable. It is also called central tendency. The formula for calculating the average is capital E within bracket x is equal to summation of xi pxi equal to x1 px1 plus x2 px2 plus till xn pxn. Variance is equal to summation of xi minus ex whole square pxi. Any probability distribution is described about the mean. If the distribution is symmetrical about the mean, it is termed normal distribution. Now you will be introduced to the three important probability functions. These functions are used to describe a continuous random variable. Examples of continuous random variables are time taken to finish a project, the high temperature during a given day, etc. First of all, let us discuss about the normal distribution. The normal distribution is the most useful and popular probability function. It can be completely specified by two parameters, the mean mu and variance s square. So for normal distribution, fx is equal to 1 divided by under root 2 pi sigma square multiplied by e to the power minus x minus mu whole square by 2 sigma square. The mean of normal distribution locates at the center of the functions and can be any real number. The variance of a normal distribution measures the variability and can be any positive real number. The normal distribution is symmetrical about the mean as shown in figure 5.2. The area under the curve between any 2 points represents the probability that the random variable will lie between these 2 points. Obviously, the total area under the curve is 1. The normal curve has the property that 68% of the population lies within plus minus sigma, limits 95.4% within plus minus 2 sigma, limits and 99.7% within plus minus 3 sigma limits. It is convenient to look for the probability value from standard table. Table 5.3 is the standard normal table. To use table, first we have to convert the normal distribution to a standard normal distribution. A standard normal distribution is one that has a mean of 0 and standard deviation of 1. Any normal distribution can be transformed to a standard normal distribution using the following transformation, where z is equal to x minus mu divided by sigma. The probability may be found from table 5.3. First, learn to read this table. Suppose you want to find out the area of the normal curve to the left of z, that is 1.54. First, go to the row corresponding to z equal to 1.5 and in that row move to the column corresponding to 0.04. Value in that particular cell is 0.9382. Hence, the required area is 0.9382. So this is the diagram for the normal distributions. So you see the mean is mu, that is in the middle, and after that we have shown the area of mu plus sigma and mu minus sigma, then mu plus 2 sigma, then mu minus 2 sigma, and the area up to mu plus sigma to mu minus 3 sigma. So this is the diagram for the normal distribution. An example illustrating the use of table 5.3. For a probability distribution mu equal to 100 and sigma is equal to 15, it is required to find out the probabilities for p x less than 125. There is a probability of x, that is random variable, which is less than 125, and the probability of x less than 75. The probability are calculated as follows. For random variable x less than 125, first of all we have to calculate the z value. Z is equal to 125 minus 100 by 15. that comes out to be 1.66. Now we have to see the corresponding values for z is equal to 1.66 in the statistical table. So from the table for p of x less than 125, that is equal to p z is equal to 1.66 is equal to 0.9515. This represents the percentage area, the shaded area under the normal curve. The random variable x is less than 75, that is probability of x less than 75. First of all, we have to calculate the value of z. So in this case, z is equal to 75 minus 100 divided by 15 is equal to minus 1.66. The standard tables provide values for positive z only, since we noticed that the area about mean are symmetric. The probability of p for x less than 75 is equivalent to p x greater than 125 because of the symmetry of the normal distribution diagram. So from table 5.3, that is p x less than 125 is equal to 0.9515. Therefore p of x less than 75 is equal to p of x greater than 125, that is equal to 1 minus p x less than 125 is equal to 1 minus 0.9515, that comes out to be 0.0485. This represents percentage area under normal curve. So this is the standard statistical table for calculating the area for different values of z. Now there is second distribution function, that is known as the exponential distribution. The exponential distribution is defined by the probability function, that is fx is equal to 1 upon mu e to the power minus x by mu, where mu is the mean and e is the base of natural logarithm and x is the value of random variable. The expected value and variance of an exponential distribution are 1 upon mu and 1 upon mu square. So this is the diagram for the exponential distribution. The exponential distribution, as shown in figure 5.4, has the characteristic that it is not symmetrical about the mean. 36.8% values will be above the average and 63.2% below the average. Examples of variables that are approximately exponentially distributed are the lifetime of light bulb, service time in a queue at banks and post office, the time required to process any task at the counters of banks, post office and railway ticket booking centers is called service time. The service time at these places fit an exponential distribution. If service time follows an exponential distribution, the probability of any very long service time is low. For example, when the average service time is 20 minutes, the person standing in a queue will hardly ever require spending more than 115 minutes to receive that service. If the mean service time is low, about 1 hour, the probability of spending more than 200 minutes is very low. The Weibull distribution, as shown in figure 5.4, is one of the most widely used lifetime distributions in reliability engineering. It is a versatile distribution that can take on the characteristics of other types of distribution based on the value of the shape parameter beta, the 3 parameters Weibull probability density function is given by fx is equal to alpha, beta multiplied by x minus gamma to the power beta minus 1 e to the power minus alpha x minus gamma whole to the power beta, where alpha is a scale parameter, beta is the shape parameter, and gamma the location parameter. The location parameter can be real number and is the smallest possible value of variable. The shape and scale parameter are positive. One can obtain different shapes of PDV curves depending on the values of three parameters. When the shape parameter is 1, the variable function reduces to exponential. For beta is equal to 3.5, alpha is equal to 1 and gamma is equal to 0, the variable distribution closely approximates to the normal distribution. This is the schematic of the variable distribution. You see that for a particular case it is similar to the normal distribution, and for a particular case it is similar to exponential distribution because of the favorable values of shape factor. Dear students, we have discussed about the probability theory. Now let us very quickly summarize what we have discussed today. We have discussed the probability theory, we have discussed the probability distribution, we have discussed the normal distribution, how to read the statistical table, how to calculate the z value, and how we can convert a normal distribution to a standard distribution. And we have discussed about the exponential distribution. We have also discussed about the variable distribution, and lastly we have also discussed few numerical related to the probability theory. Thank you very much.